Looking at quadratics, we've been transforming the quadratics into graphing or vertex form so that we can easily identify the vertex. And once you're in graphing or vertex form, it's relatively simple to find roots by just shifting the constant over to the left-hand side and then taking the square root of each side. So in order to complete the square here and get this into vertex form, I'm just going to deal with the right-hand side for the moment. I've got x squared plus 4x plus some value to complete or make a perfect square minus 3, and then I'm going to subtract the same value that I add here so that this doesn't change the function at all. The value that I need to add to complete the square for x squared plus 4x, maybe you can imagine that corner down there, is exactly 4, which is half of this 4 quantity squared. So I need to subtract 4 also. So now I have a perfect square trinomial for the first half of this. It is x plus 2 quantity squared, and then there's a minus 7 there, and this is what y equals. This is great because I can just read what the vertex is. The vertex would be the point -2 and -7. So I could graph that on the graph at the same time. I'll go to -2 and then down to -7. So here's my vertex, and let's see if we can figure out where our roots are as we continue here. Well, actually, the other thing that I can see also just from the function is that my y-intercept is going to be at -3. So I could plot that at this time also, right here at -3. And because of symmetry, I know I also pick up this point as well. This point is equidistant. I can see here this is the axis of symmetry, and these 2 points are both 2 units away from the axis of symmetry. What I'd like to know is I'd like to have an idea of where my roots are so that I can finish off the graph. And if you look, my roots occur when y is 0. That's why sometimes they're called 0. So if I was to replace this y with a 0, I would get the equation x plus 2 quantity squared minus 7. If I add 7 to both sides, this becomes 7 equals x plus 2 quantity squared. Now what's nice about having the perfect square on the right-hand side is I can take the square root of each side of this equation. And if you look at it, right, something gets squared and it equals 7. Well, that something could either be a positive root 7 or a negative root 7. So I always need to do this, and it's always kind of a mystery as to why x plus 2. Actually, I don't need the parentheses now. So the square root of x plus 2 squared is x plus 2, and the other side is positive or negative root 7. And then finally, to solve for x, I'm just going to subtract 2 from each side. So I've got -2 plus or minus the square root of 7, and that's what x is. Now there's 2 decimals there, and we could figure out those pretty quickly using our calculators. So the first thing I've got here is -2 plus the square root of 7. I'll press enter. So at about 0.645, so a little bit more than 0.6. So if I'm looking, here's 0, here's right in the middle is 0.5, so kind of right around here is about 0.6 something, right? So here's one of my roots approximately. I should probably write that number down. Actually, I'm going to write this as -2 plus the square root of 7, which is about I'll put 0.65, I'm rounding to the nearest 10. The other one is going to be -2 minus root 7. And to evaluate that, let me change the numbers up here. Yeah, so I have, as you can see, -2 minus root 7 is about -0.65, or -4.65, so -4.65. And if I was to graph that, -4.65 would be about here. So with those 5 points, I have a pretty good idea of what this parabola does. So I'm just going to go ahead and sketch it, and I'll sketch it this direction also. So again, we know our vertex. We do know the axis of symmetry. It's line x equals 2. We know our y-intercept is at 3. We picked up this extra point right here for free because of that. And we also know our zeros or our roots are occurring at the 2 points, -2 plus or minus √7.